Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design elliptic function low pass filter. So first I am going to explain briefly I will explain what is elliptic function and what are the design equations and what is the general structure of the elliptic function low pass filter. So this is the general structure of the an elliptic function lumped element low pass filter. So figure A, an elliptic function lumped element low pass filter function that has two series resonant branches connected in shunt that short out transmission at their resonant frequencies and thus give two finite frequency attenuation poles. And the second figure is the microstrip realization of the elliptic function low pass filter. So now here in this, both the ends of the lines are 50 ohm transmission line, and this is inductor L1, L2, L3, L4, L5 and capacitors C2, C4, C6. So now here in this design, for example, we use low pass filter prototype element values. So these are the low pass filter prototype element values. So G0, G0, G7, GL1, G1, GL2, G2 dash etc. So these are the prototype element values of the low pass filter. So now here in this design, G suffix Li, G suffix Ci to denote the inductive element and capacitive element, and substitute different I values. I is equal to 1, 2, 3, 4 like that. So we get GL1, GC1, GL2, GC2 like that. So the microstrip filter is designed to have a cutoff frequency. So now here in this design I am considering the cutoff frequency is 1 GHz and the input-output terminal impedance. Input-output terminal impedance is 50 ohm impedance. So the LC element which are scaled the characteristic impedance Z0, 50 ohm impedance and cutoff frequency F0 or FC can be determined using this expression. Li and Ca are the inductive and capacitive elements. So now here in this design I am considering 50 ohm impedance Z0 and cutoff frequency Fc is equal to 1 GHz and substitute G suffix Li and G suffix Ci values. So these are the G suffix Li and G suffix Ci values, and substitute that all values we can calculate inductance values L1, L2, L3 like that, and C1, C2, C3, C4 like that. And after substituting different values of I, we get the inductance. These are the inductance and capacitance values. So now here in this design I am considering the type of the material is substrate material is Rogers RT Duroid 6010 material, and its relative permittivity constant value is 10.2, and I am considering the thickness of the substrate is 1.27 mm and the operating frequency or cutoff frequency is 1 GHz. And this is the general structure layout of the designed microstrip elliptic function low pass filter. So these are the design values. So at both the ends of the substrate we can use 50 ohm transmission line. So the length of the 50 ohm transmission line is 10 ohm. So using microstrip online calculator, calculate the width of the 50 ohm transmission line. So now here the width of the 50 ohm transmission line is 1.1. So first calculate the length and width of the substrate. So adding all these values. So 50 ohm impedance, length is 10 ohms, 10 mm on both sides. So 10 mm plus 10 mm plus 8.59, 13.01 plus 11.62 plus 4.39. Adding all these values, so the length of the line is 57.61. So the length of the substrate is 57.61 mm. So this is the brief introduction to the elliptic function low pass filter design equations and design values. So now I am going to design elliptic function low pass filter using HFSS software. Select the box, draw the box anywhere in the plane. Give the rename of this box 1. The rename of the box 1 is substrate. So change the type of the material. So now here I am selecting the material is roses. So roses RT are derived 6010 and its relative permittivity constant value is 10.2 mm. So now change the dimensions of the substrate, length and width of the substrate. So now here in this adding all these values, so the length of the transmission line is 57.61 mm. So the length of the substrate is 57.61 mm. And x size is length of the substrate. So now here the length of the substrate is 57.61 mm, and I am considering the width of the substrate is 40 mm and thickness of the substrate is 1.27 mm minus 1.27 mm, and position. So the x position value is half of the x size value before representing the negative sign minus 57.61 by 2, and z position is half of the z size value before representing negative sign minus 40 by 2, 20 mm, and z position is 0. So press OK button, select fit all, press fit all, and this is the substrate. So below the substrate we can design ground plane. So take the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of the rectangular sheet 1 ground material. So change the dimensions of the ground plane. So the length and width of the ground plane is same as that of the length and width of the substrate. And the length of the substrate is 57.61 mm and width of the ground plane is 40 mm, and position and x position is half of the x size value, so that is 28.805 mm. So before representing negative sign, and y position value is half of the y size value my 20 mm before representing negative sign, and z position is 0. So press OK button, and now here the z position is the height of the substrate is 1.27 mm and the z position is minus 1.27 mm. So now press the OK button and rotate the structure. This is the ground plane and this is substrate. So on the top of the substrate we can design microstrip elliptic low pass filter. At the both the end of the substrate, on the top of the substrate, first we can design 50 ohm transmission line. So take the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet 1, and this is 50 ohm transmission line, and change the dimensions of the 50 ohm transmission line. So now here the length of the 50 ohm transmission line is 10 mm. I am considering 10 mm. So using Microstrip online calculator, calculate the width of the 50 ohm transmission line is 1.1 mm, and X size is and minus 10 mm, and Y size and the width of the 50 ohm transmission line is using Microstrip online calculator 1.1 mm, and position and X position value is 28.805 mm, and Y position value is half of the Y size value before representing negative sign, minus 1.1 by 2, and Z position is 0. So now press the OK button. So this is 50 ohm transmission line. So now select this 50 ohm transmission line, Control C, Control V, copy paste that 50 ohm transmission line. So change the dimensions of this 50 ohm one dimensions. Double click on the create rectangle. So now here position is minus 28.805 mm, and X size. Now here the X size is plus 10 mm. So now press the OK button. So this is another end of the 50 ohm transmission line. And after designing 50 ohm line, design the inductors and capacitors. And this is the general structure. And this is L1, L2, L3, L4, L5, and capacitor C2, C4, C6. So adding this L1 plus L3 plus L5 values, so the total length of L1 plus L3 plus L5 is 33.22 mm. So 8.59 mm plus 13.01 mm plus 11.62 mm, and the total sum value is 33.22 mm. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is inductor L1 plus L2 plus L3 plus L5. L1 plus L2 plus L5. Now here I am considering the name of that lane is L1 underscore L3 underscore L5. So press the OK button. So change the dimensions of that line, and axis is Z axis, and X size is that length is 33.22 mm, 33.22 mm, and Y size is and width of that line is 0.2 mm, 0.2 mm, and position value. So now the 50 ohm transmission line, X position is 28.805 mm. So the length of the 50 ohm transmission line is 10 mm, and subtracting 10 ohm from 28.805, and the resultant value is 18.805. So this X position value is 18.805 mm, and Y position is half of the Y size value, 0.2 by 2 before representing negative sign, and Z position is 0. So now press the OK button, and this is Okay, sorry. Now here position is 18 point not 05, 18.805. That is the mistake. Okay, now it is okay. So this is the length of the L1 plus L2, L1 plus L3 plus L5. And after that design capacitor C6, and the length of the capacitor C6 is 4.39. Take the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet, and this is capacitor C6. So change the dimensions of this capacitor C6, and the length of the capacitor C6 is 4.39. 4.39 mm, and width I am considering the width of the capacitor is 7 mm, and position and exposition value is minus 14.39 mm, minus 14.39 mm, and y position is half of the y size value 7 by 2 before representing negative sign, and z position is 0. Now press the OK button. Now here some gap is there, so I am increasing the length of the capacitor C6. So I am considering this length is 4.41. So now also some gap is there, 4.42. Select fit all, and after that design inductor L2, inductor L2, select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet is inductor L2. So change the dimensions of the inductor L2, and the exercise value is the inductor exercise value, width of the inductor is 0.2 mm, and length of the inductor, that is the y size, length of the inductor is 2.98 mm. So the length of the inductor is 2.98 mm, and width of the L2 is 0.2 mm, and position and x position is, so now here this L1 length is 8.59 mm, so the x position is 8.59, 8.59 mm, and z position is 0.1 mm, and the length of the width of the inductor LT is 0.2 and half of its value is 0.1, comma z position is 0. So now press the OK button. So this is inductor L2. So now design C2. So Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet is C2. So now change the dimensions of the capacitor C2, and the capacitor C2 length and width are 8.0 and 5.07 mm. Now the capacitor C2, X is the Z axis, and the X size is 8 mm and Y size is 5.07 mm, and position and X position value is, and the length of the inductor L1 is 8.59, and length of the capacitor C2 is 8 mm and half of its value is 4 mm. Okay, and subtracting that 4 mm from length of the inductor L1, so 8.59 minus 4, so 4.59, plus adding and half of the L2 width. The L2 width is 0.2 mm and half of its value is 0.1. So the total exposure value is 4.69 mm, and Y position is 2.98 mm, 2.98 mm, comma 0 mm. Z position is 0. Now press the OK button. So that is capacitor C2. So next draw the inductor L4. Take the rectangular sheet. So draw the rectangular sheet anywhere in the plane. Give the rename of this rectangular sheet is L4. So now change the dimensions of this inductor, and L4 inductor, the width of the line is 0.2, the width of the line is 0.2, and length of the inductor L4 is 6.49 mm, 6.49 mm, and position minus 4 mm, 0 comma 0 comma 0, and after that design capacitor C4 line. So take the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet is capacitor C4. So now change the dimensions of this capacitor C4. So now here this capacitor C4, so length is X size value is 8 mm and width is 3.7 mm. Axis is the Z axis and X size is 8 mm minus 8, and Y size is 3.7 mm, and position and X position value is 0 and Y position value is 6.49 mm. So that is the length of the L4, and Z position is 0 mm. Now press the OK button. And after that select 50 ohm transmission line both the ends, and inductor L1, inductor uh, inductor L1, L3, L5 line, L2, L4, C2, C4, C6 line. Select unite all. So the compensation for the unwanted, okay. So now we are the microstrip elliptic low pass filter is designed at 1 GHz and 10.2 relative permittivity, and thickness of the substrate is 1.27 mm. So all inductors and capacitors, and this is the inductor, and this is 50 ohm transmission line, 50 ohm transmission line. So this is inductor L1, inductor L2, inductor L3, inductor L4, inductor L5. So all the inductors L1, L2, L3, L4, L5, and all the capacitors C2, C4, C6. Okay, all inductors will be realized using high impedance transmission line with characteristic impedance of 93 ohms. So whereas all the capacitors, what are all the capacitors? C2, C4, C6. So all the capacitors are realized using low impedance transmission line with characteristic impedance of 14 ohms. So using that high impedance transmission line, low impedance transmission line, so the dimensions of the inductor and capacitors are calculated. So now select 50 ohm transmission line, other end of the 50 ohm transmission line, and inductor L1, L3, L5, inductor L2, L4, capacitor C2, capacitor C4, and capacitor C6. And click on unite button are all unique. So now select the ground plane and ground plane and 50 ohm transmission line. Right click on that one, go to assign boundary, select perfect E. So this is the perfect electric boundary, and after that assign port 1, port 2, assign lumped port excitation, and rotate the structure. Now change the plane, and this is y axis, z axis. Now selecting here yz plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So this is the port 1. So give the rename of this rectangular sheet, port 1, P1, and change the dimensions of this port 1. So port 1 dimensions, and axis is x-axis, and the width of the 50 ohm transmission line is 1.1 mm, that is the y size, and height of this substrate is 1.27 mm. So now the z size is minus 1.27 mm, and position and x position value is 28.805 mm, and y size value is half of the y size value before representing negative sign, minus 1.1 by 2, and z position is 0. So now press the OK button. So this is the 50 ohm transmission line, and select this port 1, control C, control V. So this is the port 2, and rotate the structure. So change the dimensions of the port 2. So now where the x position is minus 28.805 mm, and y size is, so now click the OK button. This is port 2, and assign lumped port excitation of port 1 and port 2. Select port 1, right click on port 1, go to assign excitation, lumped port. So full port impedance is 50 ohms. Select the new line integration, draw the new line integration from lower port to the upper port. So lumped port excitation, the new line integration is successfully defined. Click next button and click finish button. So this is lumped port excitation port 1, and rotate the structure. Select port 2, assign lumped port excitation of port 2. Select port 2, right click on the port 2, go to assign excitation lumped port, click the next button, select new line integration. So draw the new line integration from lower port to the upper port. So successfully defined, click the next button, finish, and port 2 is successfully assigned. Select fit all. Now coming back to the XY plane. Next assign an analysis setup. So now with operating frequency is 1 GHz and number of passes are I am considering 12 and maximum delta S is 0.02. Click OK button, and the sweep type is fast and linear count, and the starting frequency is 0.5 GHz, ending frequency is 3 GHz, and points are 101. Now press the OK button. Now select the open region. Go to the model, right click on the model, create open region. So operating frequency is 1 GHz, radiation, click OK button. Select fit all. So this is the design of microstrip elliptic function low pass filter. So now check the validation. Go to the simulation, select validate. So the design is successfully validated. Now start the simulation. Click analyze all button. So simulation is successfully completed, and after that observe the S parameter results, return loss and insertion loss curve. So go to the results, right click on the results, create model solution data report, select rectangular plot, select S parameter, S21 in decibel, S11 is the return loss, S21 is the insertion loss, click new report. So this is the characteristic curve of the, so this red color curve is the return loss and green color curve is the insertion loss. So mark the designated operating frequency at 1 GHz, set 1 GHz. So next observe the field patterns. Select the structure, right click on the structure, go to plot fields electric field, magnitude of the electric field. Click the done button. Now start the simulation. Now start the animation. So this is the magnitude of the electric field. So next observe the radiation pattern. Go to the results. Right click on the results. Create far fields reports. Radiation pattern. Select the directivity or gain in decibel. Select the families. Now the 5 families are minus 182 plus 180. So now we are selecting some families minus 180 degrees. Minus 90 degrees. Zero degrees. Plus 90 degrees. Plus 180 degrees. I am selecting some families. That family 5 values are plus or minus 180, plus or minus 90, 0 degrees. So now click the new report. So this is the directivity radiation pattern.